All right, cool. Are we recording? Yes? Okay, cool.
I think so, yeah.
Awesome. So hello, everyone. Thank you for coming out to our Python and machine learning workshop. My name is Advaita, and I am ASBME's Viterbi liaison and the organizer of our technical workshop series. And I have with me the incredible Radhika. You want to go ahead and introduce yourself?
Sure. Hi, everyone. My name is Radhika. I'm a junior studying electrical and computer engineering, and I'm a project manager for Makers. Kind of did this as a joint tutorial. Yeah.
Yep. So yeah, if you guys have any questions while we're talking, go ahead and just drop them in the chat, or feel free to honestly unmute and just shout them out. It's a small group, so I think that would be okay. But I'm gonna go ahead and let Radhika get started.
Cool. Yeah. So what is Python? I'm sure you guys have heard of this language, and there's a lot of talk about Python and industry using Python a lot. So what is Python? So Python is a high-level programming language, and it combines several elements of other programming languages from C++ and Java. So it's a procedural language. It incorporates object-oriented programming like C++ and Java, and it's similar to Haskell because it's also this kind of functional programming paradigm. And just to sort of highlight some key differences between Python and C++. So the most obvious one is that there's no semicolons in Python. Everything is done and everything is understood through indentations. So if you have, instead of using curly brackets and braces in Java and in C++, we actually indent the lines. And then that's how the compiler understands conditionals and loops. And we don't have to initialize variables and their types. So if you have in C++, you would usually do like int fruit equals 5 or like int count equals 0. So you don't have to do that in Python. You can immediately just start programming and using variables, and it will actually pick up and sort of fill in the blanks of what type of variable you're using. And I think one of the key differences is that in Python, we have something called lists, which are analogous to arrays in C++. But in C++, once you have declare an array, usually declare it of a large size if you don't know exactly how many elements you want in your array. And then you can't change the size later on. So that's a little inconvenient, and it's a waste of memory. And what's great about Python is that you can create a list and then always append to it and change its size later on, just using the append function. So that's my favorite feature about Python. It literally comes in so in handy when you're trying to do things. You can just declare your list outside, and then later on, if you decide you needed to add an element or subtract an element, you can clearly do that. And there's no need for dynamic memory allocation on all that stuff. Then, yeah, and another great thing is there's no pointers. So everything is passed by reference. You have that little ampersand symbol, so you put that in, similar to C++ references, but there isn't actually any exact pointers in Python. And then because in BME we use MATLAB a lot, I thought that we would do some differences between Python and MATLAB. So again, there's no semicolons. We use display in MATLAB instead of print. And yeah, you guys can kind of see some of the differences. So now we're going to go through some of the basic syntax. This will give you guys an intro so that you can hopefully be more comfortable with Python and write your own programs afterwards, and also in the machine learning tutorial. So there's 5 basic data types in Python. So we have numbers, we have strings, lists, tuples, and dictionaries. And we'll go into what each one is in a little bit. So this is just how you would declare. If you wanted to specifically declare a type of variable, you could do it this way, but again, it's not necessary in Python. You could simply do car equals 1, and it would be understood that car is of type int. Another great thing about Python is there's something called a tuple. It's similar to a list, but it's not mutable. So you can't change an assignment later on. Once you kind of declare your tuple, that is what it is. You can't go back and say, change the value for index 1. So once index 1 or index 0 corresponds to Apple, it stays Apple. And that has its use when you're writing certain programs. And then another thing This is also in C++, we have dictionary and maps. So in Python, this is just an example of how that syntax works here. It's a lot simpler. And strings and user input. So this is very similar to C++ and MATLAB. You can either use the double quotes or the single quotes to declare strings. And if you want to print anything out instead of doing cout, you can just simply do print. It's very literal. It's much easier to read. You can just write print whatever you want to print. It could be a variable name. It could be a string. And then for user input, instead of doing cin normally in C++, we can just do user input or input, and that will prompt the user to enter something. It's just, overall Python is more readable. The functions are named very specifically to what they do, and so you don't have to be confused about, oh, what is this doing? It's literally input. And then lists, as I mentioned, they are probably one of the best features of Python in my opinion, and my favorite function, which is extremely useful. I cannot even cannot even share this append function. Any list, so say you call your list some list, you would just do sumList.append, and then that value that you want to append to the list. And you can do that in a for loop, you can do that outside of for loop, and you can even sort, reverse, count the number of elements in your list, insert at a specific location. So you don't have to use STLs or that sort of thing that's in C++. And conditionals. So this is an example of how you would write a conditional. So one thing you have to be careful with in Python is that your indentation has to be consistent. So a lot of times you'll get errors when you're running your code because your indentation isn't consistent. So everything has to follow this indentation pattern. So if you have an if statement, then whatever, instead of using a curly bracket, you would indent once and then print out or do whatever operation you want to do. And then you have to go back to the original indentation that matches the first if statement. And if you don't do that, then the program will probably throw you some compiler errors. And yeah, oftentimes, like if you're switching back between like MATLAB, C++, and Python, sometimes you forget that the indentation matters. So that's just something to keep in mind. And if you like don't indent correctly, your program could also be interpreted in a different way. So that's something that's super important in Python, but it has the same structure as any programming language. So you have your if, and then the condition you want to check for, and then you do whatever operation within that if statement. And then we have something called elif in Python. So it basically says if the previous condition was not true, then you would try this. And then there's just the normal else statements. So if and else. And for loops, so loops are also slightly different than MATLAB and C++. So we use this thing in Python called range, and the range checks, it's kind of like the inside of your for loop in C++. It checks the range that you want your for loop to iterate over. So again, you have to declare a dummy loop variable. So in this case, it's num. And then num is in this certain range. So this would be from like 0, 1, 2. It doesn't go all the way up till 3. That's also something important to note. It goes up until this number -1, and then it does whatever you want to do inside the loop. Then there's also while loops. They're similar to the for loops, and this is simply the sort of structure you would have for that. Another difference for functions is that we have a definition in Python. So as you can see here, the syntax for creating a function is you do def. So that's, you're defining a certain function. Then you give that function a name. Then inside the name is where you would put the parameters. Now you don't have to have any parameters if, say, you're doing object-oriented programming and you want to create a constructor or a certain method that doesn't actually take any parameters, that's okay too. But in this case, we have a function called birthday. It takes in a name, and it also takes in an age. Here, age is a default parameter, which means that if you don't give an age to the function, then it will automatically use 21 as the age. So that's something cool to do. They're called default parameters. So say that you're writing a program and you want to use this like initial condition if other than like if you don't specify what you want to use this initial condition, then you can use default parameters. It will simply always use that value if you don't give it another value to use. So in this case, if we call this function with adwaita, which is of a type string, and we actually put in an age, it will print out happy birthday plus adwaita plus you are 20. But then if we only do Radhika, then it will use the default age, which is 21. Another cool thing that you can do more easily in Python is file IO. Reading in from CSV files, from text files is much easier than you would do even in MATLAB. Sometimes you have to declare the headers and it gets all complicated with the formatting. But in Python, it's actually pretty simple. You would just name what the file is. So you give the file some sort of name. You have your file object, and then you open, and then you give the file name, which is a string. And then there's several ways that you can do things with that file. So one way to do it is there are certain access modes, and these are what's listed over here. So we have R corresponds to only reading the file, W only corresponds to writing the file, R plus is for reading and writing writes as well. And then A is to just open the file for appending. So one way to do this is we can do the file object, call it, say, email, and then email equals, we're going to open the name of the file, and then I only want to read the file, so it would just be the file name, comma, R. And that's how you would do it. If you didn't want to do it this way, you can also just do the file object, and then there are certain functions that are built in for file IO, so you can just do the file name, the file object dot either close, open, read, write, stuff like that. So there's multiple ways to do file IO. Now, the incredibly powerful thing about Python is its libraries and the modules that you can import. These are built-in functions that others have designed, and you can simply import them and use them in your program. We're going to see a lot of the machine learning libraries used later on in this tutorial. And what's great about libraries is you don't have to reinvent the wheel every time. You know, there's someone who's already created a function to sort an array, or already created a function to do this sort of operation on a matrix. So you don't have to keep writing functions and methods from scratch. You can simply just import functions from these libraries. And I've listed here the 6 most common Python libraries. So one that's very, very common, it's called NumPy, and it's for array manipulation. So if you wanted to sort an array, you wanted to do specific operations with arrays, you would use NumPy. And then there's Pandas, which is more for data manipulation and data analysis. You can kind of see Pandas as an Excel substitute to Excel in Python, and you have rows and columns, and you deal with data in tables and charts. Matplotlib is, I call it like the mini MATLAB of Python. So the syntax is very, very similar to MATLAB because it's all about data visualization and plotting. So when you want to plot something, when you want to create a figure, these are some examples at the bottom of what you can do with Matplotlib, all done in Python just by importing these functions, which is really, really powerful. And then another one, SciPy, I use this one a lot in my research, and it's for scientific computing. So say you have very complicated exponential equations, or you want to find the roots to certain mathematical models, or want to take the integral, differentiate, do some sort of calculus operations. That can all be done using the scientific Python module. There are several different functions to solve for the roots of different kinds of equations. You simply just go online, look up the documentation, and it will show you what these functions can do. And then 2 other ones that are very popular are TensorFlow and PyTorch, and they're both for machine learning and doing tensor operations for writing machine learning algorithms, which we will be using towards the second half of this tutorial. So stay tuned for that. Yeah. So this is the ultimate cheat sheet for Python. I would recommend either like having a screenshot of this right now so you can use it later on. This basically like summarizes everything, how you want to print out certain things, if you want to concatenate two strings together, how you deal with lists, how you deal with tuples and if statements, examples of dictionaries and user input. This is great to have. And now we're actually going to do a couple of Python exercises that I have programmed. They're 3 really short ones. And I think it'll give us a good idea. Yeah.
Okay, cool.
Okay, so I'm going to share my screen here. Okay, can everyone see that?
Yeah, we can see it.
I'm just going to make it a little bit bigger. Okay, so the first program, if you're familiar with Terminal or have an IDE already, then feel free to like follow along with me, or you can just watch and kind of see what we're doing. It's totally up to you. I know that some of you may be completely new to programming and don't know how, don't have an IDE or how to use their terminal. So that's totally fine. If you guys have any questions about anything I'm doing, feel free to just unmute and ask or type in the chat box. But these are 3 like sort of simple exercises that use some of the basic syntax that I just went over. So the first one is to just print your name. So this is how we declare main in Python. There's 2 ways. You can either just do main with 2 parentheses, or you can do this sort of declaration. And so very simply, I want to print out my name. So I'm just going to put my name over here. And then if I want to, I'm going to enter the directory for this. And then how you run any Python program using your terminal, depending on the version of Python you have downloaded, you can just do Python 3, Python 2, Python, and then you just have your program name. Don't know why it's hanging. Let's try this again. There we go. Okay, so it printed out my name right over here. What's also nice is in C++, you usually have to do, you first have to compile your program, using G++, and then you have to enter into, doing that / whatever you named your, I'm getting a chat message here. Oh, yeah. Thanks, Adwaita. Yeah, so in C++, you first have to compile the program, and then you have to do one additional step in your terminal to see the output. But here, everything is done in one step just by running Python 3 and the file name. Okay, so moving on to another function. So this kind of utilizes, we're not doing any functions yet. This is still in the main of the program. But say I wanted to sum up all the numbers from a user inputted number till 100, and that's inclusive, so it's including 100. So say the user inputted 5, and I wanted to find the sum of all the numbers between 5 and 100. So how would we write a program to do that? So again, I have main here. Just looking at the, okay. So I have main here, and then notice how I'm not declaring the type of n. So n is just the value that the user is going to input. I'm doing it over here. So I have n equals, this is an integer value, so I want to make sure that it converts whatever the user inputs into an integer. And then once I get the number n, I'm going to initialize sum. This is very simple. This is very similar to any summation that you do in MATLAB or in C++. The only difference is that now our for loop has a little bit of a different structure. So for I, this is my dummy loop variable, and then it's going to be in the range from whatever the user inputted n and 101. And why it's 101 is because I defined in the beginning of the problem that 100 is inclusive. So we have to do one more because it goes up until this number -1. And then just like any sum, the summation is sum equals sum plus I. And then outside of the for loop, I am printing everything the summation of all the numbers. So just for the sake of kind of experimenting, I want to show you guys how important indenting is. So I'm not going to indent this piece of code right here, and let's see what it outputs. See, it says indentation error, expected indented block. So yeah, it's complaining because it doesn't understand what I'm doing. There's no condition in the for loop. So in order to fix this, I need to indent it. And the thing is that in Python, you have to be consistent with if you're using tab or if you're using spacing. So if you see here, I'm using the space bar instead of tab. But if I use tab, it will show up as a line and then the compiler will complain. So you have to do 4 spaces to keep it consistent. Okay, so let's see what this program prints out. So it's asking, I'm going to increase the size so you guys can see this. So it's asking for an input number. So let's just do maybe 8. And then I press enter. And then it returns the sum of all numbers between 8 and 100 is, you know, whatever it is. So this is one example. Software or so an IDE is basically like, yeah, it's a deployment environment. It's a development environment. IDEs can also just be another word for text editor. So this is Sublime, which is my preferred text editor. There's other text editors like BBEdit and PyCharm. PyCharm is actually an environment for running Python, so that's a little bit different. But this is simply a text editor that works with command line. And there's several ways to run your Python program. So you can use Jupyter Labs, which Adwaita will be showing you how to do later on in the tutorial. That's sort of an online IDE that you can use, or you can use a text editor with terminal. I prefer this method. Or you can use an environment that's an application that you download on your computer, like PyCharm, that works specifically for Python. But it's sort of your preference. Then there's also online compilers like Online GDB. If you guys wanted to try, if you don't have a text editor right now and you wanted to try out what we're doing, you can use Online GDB and select Python, and you can simply do that as well. Yeah, so any questions so far? Maybe I can pause here and see if there's any questions about Python, about what we're doing in these examples. They're pretty short, but just to show you how this basic syntax works. Cool, so yeah, if you guys have a question, feel free to unmute at any time. Okay, so this is another fun one that I created. It's a function to return the radius of a circle, given that the user inputs the diameter. So we're doing a couple of things here. The user is going to input a diameter. It has to calculate the radius of the diameter. Then after it's done that, it will calculate the area of the circle. So here we're actually using import math, which is a module in Python, and within math we have something which is pi. So unfortunately, like I think in MATLAB you can just use pi and there's no issue, but in Python you have to specify what pi is. So we do math.pi to indicate that we're using this variable pi that comes from the module math in Python. And that's how it understands to use 3.14, you know, whatever. Yeah, so, okay, let's go through the steps of defining a function in Python. So first we have def, which is just syntax. It's defining your function. And then we have the area of the circle. Notice that we don't have any parameters because we want the user to input what the diameter of the circle will be. If we didn't have the user inputting the diameter, then we would have put something like int diam or something, and then we would have gone through that. But so now we have a variable, we're defining a diameter, and it's of type float because What if your diameter was not just an integer? And then we are going to ask the user for the diameter. Once we get the diameter, radius is just the diameter divided by 2, and this is how you would do division. And then to calculate the area, we're doing pi times the radius times, to the power of 2. And to do squaring, you usually use 2 stars. And then there's also a function called exponent if you're doing more complicated stuff and you don't want to use the 2 stars, because that can get confusing sometimes. Yeah. Then I wanted to make it a little bit more complicated and introduce you guys to using a tuple. So in C++, you can't return 2 things if you've had experience with that. Like say you have a function and I wanted to return the age and the height of a person. You can't do that unless you put it in an array or unless you do some like cookie business. Pretty much you have to only return one item. But in Python, we don't have to deal with that issue at all. In fact, that's why we have tuples. It can return n number of things. So we just create something called a circle tuple, and what it will do is it will return the radius and the area. And then for the purposes of showing you guys if it calculated it right, I'm going to print out the tuple and then call the function in main. Any questions on that? Okay, so yeah, let's try it out and see how this works. Okay, so once again, it's asking me for the diameter. Let's say the diameter is 10.5. Okay, so it calculates the diameter, the radius, and then it also calculates the area. And notice how there's so many decimal places here. So if we didn't want to do so many decimal places, we could import numpy as np. Okay, so what does this as mean? So numpy is pretty long, and since we have to call the name of the module each time we use it, we just abbreviate it as np. So we could have called this anything. We could have called this like SS, or we could have called this like, I don't know, N, but we're calling it NP. So that's just an abbreviation for the module. And then what we can do is, here's the area. I think the syntax is like NP round.
Can we do that for any library? Like if we like felt like math was too long?
Yeah, you can do that for any, yeah. So if we did like math as M, we can try that. I don't know why my terminal is like hanging today. It really just doesn't like. Yeah. So pretty much anything you want to do. But there are certain conventions for modules. So like NumPy most of the time goes as NP. Pandas usually goes as like PAND, I think. And then like matplotlib usually goes as PLT. So there are like some sort of naming conventions that people use, but in principle, you can call it anything you want. Let's see in the chat here. Yes, yeah, VS Code is great. And also VS Code, it allows you to like edit, multiple people can like edit the same doc at the same time, which is really cool. There's also another thing called like REPL, REPL.it. I'm putting that in the chat. Yes, yes. It's really great, especially in quarantine. I was always wondering, like, is there like some sort of Google Doc for code? Like, what if I was working on a project with a partner and I like wanted to make some sort of edit, and like GitHub is great, but right now I'm like doing a project and I'm facing this issue because I'm making some edits and then my partner is making some edits, and like every time we have to consolidate, and it's so much like juggling, especially if you have multiple files. So using something like REPL.it or like VS Code where you can edit the same file is super helpful. Yeah, what were we doing here? Oh yeah. So I think this is like NP round, and then we would, let's see if it complains about that. But there's a certain function in NumPy that is for rounding. Actually, I don't think that is the syntax. Another great thing is you can just search how to say like round a number in Python, and there's like a whole bunch of documentation online. So whenever like I don't remember how to do something, because there's so many like functionalities in Python, and like you're not expected to memorize everything. I think a lot of young programmers feel like they need to know how everything works all the time, or what every function is out there, but in principle you can't, and once you're going between multiple languages, it's hard to keep track. So you can always just look online, and there's so much documentation, especially for Python. So yeah, here's an example. It's using round, and it has the value that you want to round, and then also how many decimal places. So let's try that out over here, and I'm pretty sure we need to do np.round. Okay, so let's do here. We have area equals to np.round. Oops. Area, and then 2. And see, it cut off the all the other decimal places. But sometimes you might encounter a floating point error, which is if you're not dealing with enough decimal places and it's making an approximation for you. Like in research, I've sometimes encountered floating point errors where I needed to be using a lot of decimal places in order to get an accurate answer, and it was approximating something as 0, even though it wasn't. So that's something to keep in mind. You don't always want to use NP round to round your values, depending on what your project is doing. Yeah, so that's kind of the exercises I had planned for today. Since we do have a little bit of extra time, we could do another project. Let me find one. But yeah, before we do that, does anybody have any questions on Python? Anything you want me to explain more, go over?
I just had a quick question. It didn't seem like you needed to write end at the end of a loop. Did I miss that, or is that just part of the language?
Oh yeah, like in MATLAB, how you write end?
Yeah.
Yeah, so in Python, you don't have to do that at all. So the indent, here, I can show my screen again. The indenting will immediately give you an idea of what your, oh, I guess we don't have any for loops. Oh yeah, we do. Yeah, so the indenting takes care of that. So if I have a for loop and then I indent and then I go back to the original indentation, then it indicates that you're done with what you're doing in the for loop. Now, say I had like an if statement, like say if the sum was less than 0, then I would need to indent again because I need to be inside of the if statement. But yeah, that's basically how for loops are done in Python. No end required. You just have to specify the range. Sometimes you can even do, like, if there's not a specific range and you just kind of wanted to like auto range, you can just do for I in range without anything inside of here. And that works sometimes too. So it's very flexible. And what's nice is that like if you don't tell the program certain things like the type of the variable, it can deduce what you're trying to do. Now that can be a good and bad thing. Sometimes it's good to be explicit and not let the program assume certain things because it can assume the wrong things. That happens all the time. But yeah, I think like if you're a beginner programmer, and it's a lot to keep track of in C++, so Python is a great way to introduce yourself to programming. And it's good practice to be as explicit as possible. So don't let the program like fill in the blanks for you, but that's why you get less compiler errors with Python compared to C++, because if you didn't explicitly tell it something, it will just, make its best guess given the context of the problem.
I see. Thank you.
Mhm.
Right. Yeah, can you explain like the different versions of Python? Because I think I have a project and I think I downloaded one version of Python, but it needs another version of Python to run. I'm like not
Yeah.
sure. Yeah.
Yeah, so there are different versions of Python. I'm pretty sure Python 3.8 might be like the latest version. And yeah, the reason why you need to use the right version, it's similar to like C++, is that so that the compiler knows what version you're using. So if you're writing, say you're like, what do I want to say? There was like a project I was doing, and we had installed Python 2, and we were doing everything in Python 2, but then there was a certain package that we needed to download, and that package is only supported by Python 3. So therefore, we needed to install Python 3 in order to use that package. So there's certain packages, especially newer packages, that are only supported by newer versions of Python, and that's why you need to use the right version. Because there's new capabilities that are added to the language, and that need to be supported in certain packages. So and applications. So that's why it's imperative to be using the right version. Cool. Any more questions?
Yeah, so it looks like tuple is like, I don't know, I guess the list is like an enhanced version of tuple. And in what cases would you rather use tuple over list?
Yeah, so the difference again between a tuple and a list is, in a list like an array, you can always reassign certain values. So say I have a list that has 5 elements, and then later on I decide that, oh, the first element is a 0, but I want to make the first element a 1. So in a list you could do that. You could just, here I can share my screen and sort of type in the text editor. So say I have a list and it's equal to, say, like 1, 2, 3, 4. But then I decide, oh, like I actually want the first value to be 4. So I can do that in a list. But if this was a tuple, I would not be able to do that, because you can't go back and reassign indices and like values of certain indices. So that's useful, like if you're creating a program and you want to make sure that it's, the same 4 people in a tuple, and that you can't change that, then that's when you would use a tuple. And then you can also use tuples if functions have to return multiple values. That's like pretty much the most common way I've used them. So like in the summer, I worked on a project that was modeling these COVID-19 respiratory droplets. I can actually show you guys some of the functions I wrote with that.
Could you explain what you mean by returning multiple values?
Yeah, I
Okay.
can show you. Let me just pull that up. Pyram. Okay. So there's a couple ways I could explain this. So this is one program that I wrote. Okay, so let's go back to, okay, a simpler example is that if I wanted to return 2 values in a function, so in this case, I wanted to know the radius of the circle and its corresponding diameter. So that's why I created a tuple that will hold those 2 values together. And why that's important is that I can't go back and like change the first element in the tuple to another variable. It's always going to be radius no matter what. And that's why tuples are important. If you want consistency and you want to ensure that you can't change what the first index of that tuple is carrying, that's why you wouldn't use a list, because in a list, you could like reassign the radius to diameter and start like returning the diameter. So that's why we would use a tuple. For one reason, so that it always returns the same variables, and 2, so that it can return multiple variables. So I created a tuple here. This is the syntax for it. And then I could return, if this was a function and I wasn't printing anything out, I would just return circle tuple. just like that. And so every time it returns circled tuple, it will be 2 values. And another example of that is in this program that I wrote over the summer. This was my research project. Okay, so I created a function that tracks the position of these respiratory droplets. And I wanted a function, I needed to find how much these droplets were traveling in the X and in the Z direction. And I didn't want to create 2 functions that calculated the position in the X and calculated the position in the Z, because it's pretty much the same equations, and it's more efficient to just do it in one function. So a way to do that, and I needed to use these positions later on in other functions. So I needed to return them both in this same function. So the way I did that was I created a tuple that would return both the X position and then the position in the Z direction. And then when I call this function position, so then when I call this function position, it has 2 values. So then I need to specify, well, the first, the 0th element, the first index is actually corresponding to the X direction, and then the second is corresponding to the Z direction. And yeah, that's how you would get those values from the tuple to use somewhere else.
I see. And it looks like when you're indexing it, you index it the same way as you would index a list with brackets.
Yeah, so with brackets, and it starts at the 0th element.
All right, cool. Thank you.
Mm-hmm. Yeah, so we can, this is actually a great piece of code to kind of look at and understand. So I was using different libraries in Python. I was using SciPy. SciPy, again, is the scientific Python library. And so from SciPy, we're importing root. Root is a module that contains different functions to find the solution to equations. So I'm using root over here. So root finds the roots of the exponential or a nonlinear equation, compared to if you just had like a linear equation. Again, so I'm using math. Math is a really common one to use in Python, and NumPy. And then matplotlib is to visualize data. So then these are different functions that I use. They take in certain parameters. Notice that I didn't indicate the type of these parameters. That is sort of figured out by the compiler and the program. And we can take a look at maybe, oh yeah, this was a really cool thing. So I wanted to learn how to integrate in Python. So I knew how to do it in a for loop by doing a sum, or using like traps in MATLAB, but like how would I do that in Python? And in my project, I actually had a function that was a function of multiple variables. So I needed to do some multivariable calculus. So I need to take the integral with respect to one variable, but the function was a variable, the function itself was a function of 2 variables. So I used this really powerful function in SciPy called integrate, and within integrate, that module, there was a function called quad. And so I called this, and it integrates this function. My function is called concentration, and it integrates it from 0 till whatever the user inputted for time. And then what I'm doing here is I'm telling the function which variables do I hold constant. So if I have a function that takes in multiple variables, I only want to integrate with respect to time, and I want you to treat everything else as a constant. So this is how you would do it. And this limit here, this is another parameter, and that just limits how many divisions you're doing for the integration. So if you're doing any numerical integration, even if you're doing it on a computer, it's basically doing a Riemann sum, and you're taking little pieces under the curve and adding it together. So this is limiting the subdivisions to 50. So I could have a max of 50. And that's because this function actually takes quite a bit of time to run. Over the summer, it took like 4 hours to generate one curve. So the integration is pretty heavy. Everything in scientific Python does take a bit of time to run, as long as it's not too complicated. Yeah, so that was that. And maybe I can show you some code for actually plotting, since we will be using matplotlib in a second. Let me pull that up. Plots.py. Okay. Cool. Well, I'm not sharing. Okay. Okay, so this was the follow-up piece of code. Okay, and another thing that you can do is you can import functions in Python. So instead of like doing hashtag, if you're familiar with C++, you would do like hashtag include and then the file name. So say the file name was like rem.cpp. So then it includes all the methods that you wrote in your previous file. But in Python, we actually have a little bit more flexibility. If we didn't need the entire file, we could just import certain functions from another file. So notice here, my file was called rem. So from rem, I'm importing these different methods that I wrote. And that's something that is useful because then you don't need to import the whole file. And it's just like very specific to what task you're trying to do. So matplotlib is the library where you can do all sorts of graphing. It's very similar to MATLAB. And so what I did here is I created several functions that actually generate plots. So traditionally you could generate plots just in the main of the program, and you don't need to do it as a function. But in my case, since I had a lot of data and I wanted to make the whole program cleaner, I did them as smaller functions. So yeah, I'm creating a list here. These were 4 values that I wanted to iterate over. And then I'm not going to go into the details of this. It's a little bit complicated. So I'm generating my data in the for loop over here. And so I'm iterating over initial D list. And initial D list is a list of all the diameters that I created over here in this range. And then to plot it, another thing is I'm appending everything to an exposure array. So I created an exposure array. See how I declared it as empty. You can declare an array as empty in Python. Not going to throw errors. And then once I declare it as empty, I can go back in my for loop, and each time for each initial D, it will append my exposure value to that array. So then all of a sudden your array is not empty, it's full of data. And then I simply just call that array over here and I plot it against whatever X values I wanted. I can label it and it will plot it. These plots I would show you, but they take a couple of hours to generate. So we will not do that today, but you'll see how to generate plots in a couple of minutes with Adwaita. Yeah, so this is how you basically plot in Python. It has very similar syntax to MATLAB. And yeah, so as shown here, I abbreviated matplotlib to PLT because I didn't want to type this out each time. And every time I wanted to plot something, I did plt.plot, which means that I'm using this matplotlib library, and inside that library, I want to use the plot function. And then if you're familiar with MATLAB, this is just labeling the x-axis, the titles, the y-axis. And then if you have a legend, it's very simple. You just do legend show or just plt.legend, and then you would show your entire plot. Any questions on that? I would like to actually show you guys one of the figures. So let me see if I can run this really quick and you can actually see how it works. So, okay, respiratory exchange model. Okay. Just need to see what directory I was in. Okay, so let's actually do the xplot. Okay. Okay. And then it was main code. Okay. Okay, that's interesting. This might have been a buggy code, so I'm not gonna waste your guys' time in debug, but might need to like import some other module here. I don't know why that should work. Yeah, but anyways, does anybody have any questions about Python plotting, some of the other things we saw? That is really weird.
Do you need to like download that? I don't know why Matplotlib wouldn't already be like downloaded. But
Yeah, actually, so what I just did was I updated my shell, and I feel like it's causing some problems where I need to like re-download packages. I like just switched to ZSH instead of Bash. So that might be the issue.
yeah, that's probably it.
Yeah. Anyways, sorry I couldn't show you guys these plots. Yeah, but if there's no questions, I will stop sharing so that Adwaita can move on to her portion of the tutorial.
All right, cool. I'm gonna go ahead and share my screen. Hopefully you guys can see it. All right, cool. Can everyone see this? Okay, cool.
Yep.
Awesome. Thank you. All right, so today for the machine learning model we're specifically going to be building is a decision tree. So like when people say like machine learning or AI, there's like so many different types of models you can build, like everything from like really simple models such as linear regression, which is essentially just like drawing a linear line through data the same way you would have like if you were in high school, like in calculus, like drawing a line and trying to use that to predict, you know, a trend in your data, all the way to like neural networks, which is essentially a pretty, when you say and when you think machine learning, I think you generally are thinking of neural networks, just like, for example, when you see like image recognition software and things like that, essentially it's like a really huge matrix of like summations that create different weights to predict something depending on what you're doing. So there are a lot of different things you can do. What we're going to do today is decision trees. But before I get into exactly what a decision tree is, I'm just going to talk about machine learning in general. So the way that machine learning works is usually you can't just like build it and then use it on the world, because the way these model works is they learn from data and then they use that learning to predict something based on the data they've learned. So it's almost like you're creating like, oh, I see we have chat already. Oh yeah, no problem. Thanks for coming, Rachel. But essentially it's almost like you're building a shell, like your model, and then you're filling it with data. The model will use the data to learn what it needs to then go out into the world and make predictions based on it. So you're just teaching it, and that's kind of your job. So the way you teach, the way you train a model, sorry, I should probably just keep the, oh no, everyone has to go for class. Okay, bye guys. So what we're gonna do, what we can see here is that essentially you have this area called learn model. So you build your model, and building a model is usually pretty simple. There are a lot of, why we're teaching this with Python is because Python has so many like already made functions that'll essentially like create your model for you with like a single line of code. And then using that single line of code, you put in data, often called training data, which is this training set we see on the left-hand side here. And you use that to like teach your model so that your model can learn from the training data. And honestly, I think the hardest part of machine learning is not building the model. Like I said, there are already a lot of Python libraries that, like Radhika explained some of them, that are built to handle that for you. The real hard part is getting good, clean data that isn't like garbage to train your model on so that the predictions it makes are actually like relevant and useful. But once you do that, once you take your algorithm and you train it based on this training data, you have your working model, and then you apply, which is on this right-hand side here. And then you apply that model using new data, which is test data that your model hasn't seen before. And you usually use that data to see if your model can predict values that actually match up the real world values that we're trying to see. Because again, if you get garbage out, that's like not useful. It's not useful if your model can't predict something that actually matches with what you want to see in the real world. So that's why you have these two sets of data, training data and testing data, and you use both to make sure to get your model working and then to verify that your model is working the way it should. So we will be working with both types of data, training and test data today. So I'm going to specifically talk about decision trees, which is a type of classification algorithm. So essentially classification means that the goal of this machine learning algorithm is to take your data and to put it essentially in different bins. So classify it based on different attributes that this data has. Specifically today, we're going to be looking at the Titanic data set. So we're going to be giving our model a bunch of information about different passengers, like what class they were riding, like first, second, third class, their gender, whether they had siblings, whether they had spouse, how much they paid for their flight, or another flight, their ship, their sail. I'm like forgetting the word, but essentially for their trip, how much do they pay for that? What cabin they were in, what was their cabin number? All this information we're going to throw at the model. Well, not all of it, but anything that's relevant, we're going to throw at the model. And then the model is going to use that to tell us whether the passenger survived or died. So it's going to classify it into two different bins. Specifically, this model is just going to tell us like survive or die, but other models can tell you more than just like a binary. There can be different like bins it classifies it into, but specifically for this data set, this is what we're going to do. So the way this decision tree works, I'm going to go pretty slowly here because I want you guys to understand what a decision tree is before we move on. Last time we taught this, we had a little issues, I think, where people weren't quite understanding what this algorithm does. Essentially, it's kind of asking the data a bunch of yes or no questions, or like very easy, like, are you this or are you this sort of questions, in order to like bring it down and classify it. And the way it does that is by like working down this tree. And what your model is actually creating is this list of yes or no questions that it can ask the data to give it the results that it needs. So here it'll tell you whether the passenger lived or died through these series of yes or no questions. So here, if we can work through this little model we see up here, this little tree, again, this looks like a tree, that's why it's called a decision tree. But we're gonna ask the data, like, what class are you in? Meaning like, did you travel first class, second class, whatever? And if you are greater than class 2.5, so if you're class 1 or 2, or so not greater. If you're greater, then you're just class 3. If you're class 3, chances are you died. And the data can tell you that like almost right away. But let's say you weren't class 3, you were class 1 or 2, then I'll ask you more questions. Well, were you older than 16 or younger than 16? If you were younger than 16, which again, matches kind of what we would imagine, that probably means you were a kid and you survived because you were probably like given priority with the lifeboats, for example. And let's say you were older than 16, then again, I'll ask you what class you were, and depending on that, the model will tell you whether that passenger would have lived or died. And these numbers we see inside these leaf nodes. These leaf nodes are just like where the tree ends. So once it's asked the different questions, where's it going to end up? Again, lived or died, which is what we're looking at today. This number 370 out of 501 means that out of 501 passengers that were, in this case, third class, 370 of them died. So that's how accurate this question was to give you this answer. Because, and then you like continue these. So these other like not 501 would like go on here because you guys obviously more than 501 passengers. And that means the rest lived. So out of the 370, whatever 501 minus 370 is, the rest lived. So this just gives you data as to like how many people actually would they predict would have lived or died at these different leaf nodes. But as you can see, when you say yes, this algorithm is going to tell you everyone who was third class died. So obviously it's not 100% accurate because only actually, when you're looking at the data, only 370 of these people died. So we'll later look at how you can use this sort of measurement of accuracy to see how accurate your model is, and then you can change your model based on that, or decide that this model isn't going to work for your data. So again, we're generating this model based on training data, and then we're testing it, for example, to get this 370 out of 501 number using testing data. So we're using training data to make this and then testing data to test it. Does that make sense? Does anyone have questions on like what a decision tree is? Because if we're stuck here, the rest will be difficult.
I'm a bit confused about what you mean, like you have to collect two different like data for the training and the testing.
Mm-hmm. So when I say two different sets of data, what it actually is, or specifically for this Titanic example, we're going to take all the passengers who sailed on the Titanic and we're going to divide it into two portions that don't like mix with each other. And we're going to use one portion, the smaller portion, to create the model, and the bigger portion to create the model, that's our training set, and then the smaller portion to test the model. Does that make sense? So we have all this data and then we're just splitting it into training and testing in order to create and then verify our model. Does that answer your question, Princess?
Yeah.
Okay, yeah. So when you're out there, like before you're creating your model and you're just trying to get as much data as you want, you're not sitting there thinking like, oh, would this be good test data or good training data? You worry about that later. You use the machine to like randomly split it into testing and training data, or randomly divide the data so that it's like designated into one without it. But you need to have like two portions at the end of the day. Does that make sense?
Yeah.
Okay, cool. All right, any other questions about like what a decision tree is or how we would train it? Okay, cool. We'll be making one later, so you'll probably have more questions as we're doing it. Okay. Now we're going to talk about measuring your model. Now that you've created your model, you use the training data to train your model. You want to see if your model is worth anything. And the way, first we're going to look at how your model trains itself, and then how you can make sure that the training it did for itself was accurate based on the training data. So the machine, the way it works, so we talked earlier about how there's like different nodes in a decision tree, like different places where it asks essentially like a yes or no question and then keeps splitting. And your tree will kind of just keep splitting until it can assign all the data to accurately say whether, in this case, whether your passenger lived or died based on the passenger data it has. The way your machine finds the best split is it's trying to create the most homogeneous groups possible. So essentially when it asks a question and it gets a yes or no answer, it wants all the data in the yes node, as we can see, for example, here, N1 to look the same, and all the data in the no node to look the same, because that means that the question was good. It was a really good question if you can ask it of the data and it split the data accurately. Like, for example, if you were trying to pick candy, let's say you had a big candy jar and you only like chocolate, but the jar is filled with both like Jolly Ranchers and Tootsie Rolls, but you only like Tootsie Rolls. Tootsie Rolls are sort of chocolate. I don't quite know if that counts. The problem is they're shaped the exact same. And so if you were, and let's say you had to close your eyes and just pick a candy, because your model obviously can't see the data and automatically tell you things, right? As in sees like the way we visually see. So your model is trying to pick a piece of candy for you. Chances are, if you tell the model, if the model asks the question of the candy, or if you, let's say you're the model, you're gonna like figure out with this candy example. If you say like, well, I want a small piece of candy. The problem is Tootsie Rolls and Jolly Ranchers are like the exact same size. There's like literally no difference between them. So if you're gonna like say, well, the candy I want is going to be small, that isn't gonna necessarily divide the candy jar into like Jolly Ranchers and Tootsie Rolls really easily. So that's a bad question. That's a sort of question where if you were to like use that to sort your candy jar, you'd end up getting a lot of Jolly Ranchers and Tootsie Rolls mixed up in your two groups. And you wouldn't have divided into like a nice Jolly Rancher group and a nice Tootsie Roll group. But let's say you ask the way you decide to split your candy is by figuring out what color the wrapper is. So Jolly Ranchers have clear wrappers, so you can see the color right through. And Tootsie Rolls, the wrappers are brown. So if you ask the question, like, okay, I'm going to divide it into two groups based on whether or not the wrapper is brown, that you would probably get all Jolly Ranchers in one group and all Tootsie Rolls in another group. And that would be a really good question and a really good way to split your candy and for you to get the candy you actually want. So the machine is doing the same thing. It's asking questions that do a really good job of splitting the data so that one group has all of one thing and the other group has all of another thing. So for example, in our Titanic example, we'll have one group with passengers that mostly survived or all survived, and one group with passengers that died. And the way your machine does this is it just asks the data a bunch of questions and tries to find which question creates groups that are the best divided. And once it finds that question, it'll like kind of jump down to that node and then ask the remaining data a bunch of questions more. And it'll just keep doing that until it can get a bunch of groups that all have just people who lived or just people who died, for the Titanic example specifically. Does that make sense? Does my analogy make sense? It was a bit out there.
It made sense to me.
Okay, great.
So,
Okay,
so it will know like if the question was like good enough based on, I guess, the outcome that you were looking for. Like
yeah.
it will know this, like you don't have to like go through it and check that.
Yeah, it will know this. And it'll do like a bunch of these questions in like a couple of seconds. That's why you need a computer to do it, because it goes through any possible, because imagine like when you have the, like I was saying earlier for the Titanic data, you're going to have a bunch of different like attributes to this data, like all the different data points. So it needs to go through a bunch of different questions very quickly. And that's why it becomes machine learning, because the computer does it to predict something as opposed to us doing it by hand. But technically, we could do it by hand. As you can see, this calculation is pretty simple. But yeah. Does that make sense?
Yeah, that makes sense.
All right, cool. So I'm gonna ask you guys a question. We have two different splitting variables, A and B. So kind of two different questions the machine is asking. Which one do you think is a better splitting variable? There's some kind of what I've said so far. Remember, we're looking for like homogeneous groups.
Probably B.
Yes, good. Okay, this is great. Last time we taught this, no one got the answer and I was like concerned. But I also didn't have that incredible candy jar analogy, so maybe that was it. I'm joking. I don't know if that was it, but yes, Anthony, you're correct. As you can see, if any of you guys didn't get it, we can see there's a lot of C0 in node 3 and a lot of C1 in node 4, which means that it did a really good job of splitting what was C0 and putting it in one bin and what was C1 and putting it in the other bin. In A, we don't see that at all. It's really evenly mixed. That's pretty bad. There are different like mathematical equations and like indexes that the machine uses to do this. We're not going to go over them specifically, but they're also like the math is not simple. It's pretty simple, as you can imagine. You're just like finding a fraction. So yeah. All right, so since the way your model works is it continues to ask these questions all the way up until there is literally like only any one category in a given node. So like only people who lived in this group and only people who died in this group, it can get really well fitted for the data you're training it on, because obviously it works perfectly 100% of the time for your training data. But you don't want that because you don't necessarily know that your training data is 100% representative of all the data out there in the world. And chances are it's not, because it's just a subset of data you've created to train your model. So that's why you need to make sure your model isn't susceptible to overfitting, which just means it works really well for the training data, but doesn't work very well for the test data. And we can see that here on this graph, because on the left-hand side, we have the percent error, and then which is the y-axis, and the x-axis is number of nodes. So essentially, how many questions is the model asking your data? So when you get all the way up to like 250, it's a very low percent error for the training data, which means it's really, really good for the training data. But as you can see, the percent error for the test data, which is this blue line, went back up because it no longer is applicable to a greater population because it's so well fitted to training data. So you kind of want to figure out where obviously you want your model to be fit for what you're trying to do. You want it to be able to make meaningful predictions, but you also don't want it too well fit to just the training data because then it no longer is applicable to any other situation. So that is kind of something you can deal with machine learning in general, not even specific to decision trees. If you guys are making your own model, that's something to think about. To address overfitting specifically with decision trees, the way we're going to do it is we're going to grow the tree out to its entirety. So essentially you create as many nodes as physically possible so that your tree is 100% accurate for training data, which as you can imagine is not good because that means we're sitting down here at 250 nodes. And then we prune it back. We kind of take away the very bottommost nodes because again, it looks like a tree where we're going to just have a bunch of nodes at the bottom. We take out the bottommost nodes, kind of like we were pruning a tree, you know what I mean? Like using shears to clip away at the leaves on the edges, all the way back until we get your model is still accurate for the test data and accurate for the training data, but not over accurate for the training data at the expense of, other data such as the test data. So the way you would normally do that, like I said, is grow it out to its entirety. And as you guys can kind of see with this image, kind of find an error rate that you think is acceptable for the test data and for the training data and just go with it. Go with that. We're not going to be doing that today because that involves, creating a loop and going through a lot of different nodes, and that would take time. But hypothetically, if you are building a model from scratch, that's what you should do. So just keep that in mind if you're building a model on your own. Okay, so now the last thing I want to talk about before we move on to actual coding is dummy variables. So the library and the functions we're going to use today to build decision trees, the way it accepts data is only in the forms of numerical data. So you have to give it numbers. What does that mean? That means you can't give it characters, you can't give it strings as data because it won't know how to process that. And there are other models and other libraries that would be able to process that, but essentially what that means here is that anytime we have categorical data, so categorical data is like the Jolly Ranchers versus Tootsie Rolls example I was giving you. There's only two types, and we all know the different types, Jolly Ranchers, Tootsie Rolls. But your machine can't read the string and be like, oh, Jolly Ranchers is different from Tootsie Rolls. At least the model we're going to be using, the function we're going to be using. So the way you would convert that, as they converted it here, is you assign numbers to each different type. So here, for example, there are 4 different types, types of pets. There's pet 1, 2, 3, and 4. Imagine they're actually named things, because this is a little not helpful because they actually have numbers here. But the way it's going to work is you take this categorical data, which is assigned 1, 2, 3, 4, these 4 different types of pets, and you essentially create 4 columns in your data, because your data is going to be at the very beginning just like a huge matrix of data. And you're going to say there's a column called pet 1, pet D2, pet D3. And if your pet is type pet 1, there's going to be a 1 in that column and a 0 in all the other columns, because it's not, obviously a pet that's pet type 1 isn't pet type 2, 3, or 4. And that same way, you do that for all the different types of pets. So there's a new type of column for each type of pet. As like an example, if you had hundreds of types of pets, that would be a problem. You know what I'm saying? And you probably wouldn't want to code your decision tree the way we're coding it. But today we'll only be using that, for example, for male and female, where obviously this data was collected back in a time when gender binary was a thing. So there is no not male and female, which isn't necessarily appropriate. But for the sake of our data, that's the data we have. So there's only going to be 2 columns, gender type M and gender type F. And each type of passenger will either have like a 1 under like gender M or a 1 under gender F. And that'll tell us what gender it is. And we can use that and put that into our model, and our model can understand that. Does that make sense? Does this idea of a dummy variable make sense? We're essentially replacing categorical variables with like a dummy quantitative variable, if that makes sense, just like numbers.
Isn't this a lot like basically naming a logical vector?
Can you like expand what you mean by that?
Like, because we just did this in 210, where it's like you set the vector, you say, I don't know, a dummy variable equals pet. Oh, I have to look at the example again. Never mind. I forgot how the syntax looked.
No, you're all good. You're probably right. I don't remember exactly what you're referring to, but this is definitely not something that is just used in like machine learning models. It can be really useful elsewhere as well. For example, if any of you guys ever do like state machines, if you're an electrical emphasis, any of you guys, there's a way for you to code your state machine so that you can represent each state like this, where you use, there's like, let's say there's 5 different states for your given state machine, as in there's 5 different states your machine can be in, and you'll have 5 different columns, and it's just like a 1 for that given state, and then like 0s for all the others, and it's a way of coding. It's called like one-hot coding, but this is definitely not something that's only a software specific, machine learning specific thing. All right, cool. So, all right, so this is just a summary of our data, our Titanic data that we'll be using today. These are the different variables on the left-hand side. So these are different fields that each passenger will have data for. And then the definition just gives you more information as to what like age, for example, is age in years and things like that. And the key will just help you out just in case the data isn't self-explanatory. For age, for example, a number that's easy to understand. But survival, 0 means that they didn't survive and 1 means they did survive. So the survival, for example, will be our target variable. This is the variable we're trying to predict for, whereas all of our other variables are just like fields that are going to help us inform our model to predict whether or not the passenger survived. So this will be helpful just as we start building our model, and I just want to introduce that. Also sources, sorry, before we finish. As we mentioned earlier, Radhika and I are in a great class 250 together, but I have a couple other classes I took. We totally recommend these classes if you want more information on Python or machine learning, and these are just some sources I have. I will also put the link to this slide deck in the chat because I think it'll be useful for you guys. I know we had like a summary page with all the coding here, that might be useful as we begin coding. So I'll put that in the chat. And I'm gonna go ahead and start. So the way I'm gonna do it is I'm gonna code this live on Jupyter Lab, but I did email everyone already the data files that you're gonna need and the completed demo, just in case you don't want to like sit there and try to code things as I'm coding them. You can just like copy paste from that. Honestly, I'll be doing a lot of copy pasting from that as well. So that'll make like life easier for you guys. So before I start, does everyone have access to those files? What you're going to need is there's a file called diabetes.cs, or not diabetes, sorry, Titanic survival or something .csv. And then there's like a completed demo file. That's like a .ipynb file. So it's like a Python file. Does everyone have access to that? Everyone who's going to be coding with me in these.
Yeah.
Okay, great, cool. Okay, so I'm going to share my screen and open up Jupyter. So like we were mentioning earlier, Jupyter is an IDE, which essentially just means you can code on there and code Python specifically. We have other, actually now more recently, they've introduced other languages, but essentially it's a really great place to code Python. It can be interactive. You can, if you guys take VME 202, you'll probably be coding in Jupyter. And like, it's an easy way for you to share files. I don't know if you can code at the exact same time, like you can do with some of the other like Ripple.it and stuff, but it's a really easy way to share files and kind of collaborate and keep everything online if you're interested in that. So what we're gonna do is we're gonna go to try it in your browser. If you just Google Jupyter and try it in your browser, you should get it. We're gonna use Jupyter Lab today. So just hit Jupyter Lab and it's gonna create like a repository for you. So essentially a place where you can upload your files and work with them. This will take a little bit of time, but let's start. Is anyone having trouble getting to Jupyter or getting to Jupyter Lab specifically? Cool, I'm gonna take that as a no. Also, can you guys still see my Jupyter or do you guys see my PyCharm right now? Jupyter still? Okay, cool.
Oh, I think, actually, I'm not sure. We're fine.
It's okay. Is it a white screen or a black screen?
Neither. We just see the, like the launcher.
Okay, perfect. All right, cool. All right, I just want to make sure like when I refer back to my notes, you guys aren't like staring at that as well. Okay, so when you open up, first I'm going to explain just kind of the Jupyter layout here a little. On the left-hand side, this is kind of like your file explorer or where all your files, or your terminal essentially, where all your files are saved and you're in your current directory and all of that. For example, right now we're in the demo directory because that's just like what Jupyter opens up to. This is where you're going to upload the CSV files we want to use because it's going to take from here when you load in your data. This is also if you already have pre-created code that you just want to upload to Jupyter, this is also where you'd upload it. So that's what we're going to do right now. We're going to click upload files on the top here. And I am going to go upload my Titanic dataset. And you guys should as well, or else your code will not work. So go ahead and do that. Okay, so it's called Titanic train. That's the data. So as you can see on this left bottom, it showed up. It's a CSV file. So CSV stands for comma separated something, but essentially it's a file. It's just an Excel file, but the data is separated by commas if you were that curious. So when you read it in, that's how the program can tell you what's like how to read in the data essentially. So when we're in this notebook, we're going to click on Python, which is this first button, because that's what we want to code in, Python 3. Like Radhika was mentioning earlier, there's different types of Python. We're using the most updated Python 3 version. And you're going to come up to here. So Jupyter is really cool because like when you use, I use PyCharm. When you use PyCharm or when you use like Microsoft VS Code, like we were talking about earlier, or when you're just using even a text editor, when you run your code, you essentially, if I'm not wrong, unless you like specifically select certain parts of code to run, it's not like MATLAB, you're just going to be running all your code through. MATLAB also you can run all your code through, but you can also like really easily pick specific sections just to run. Jupyter is nice in that it allows you to pick those specific sections and just run sections of code. So that's why we're going to use it today, so that you guys we can just run piece by piece instead of having to rerun all the code every time, because we do have a lot of data and we don't want our computer just like reprocessing that over and over again. That'll take a while. So are we all here? Does everyone have a Python file open? Anyone who's doing it with us? If not, you can also just watch me do it. And does everyone have their data uploaded? Someone having trouble? Actually, I'm going to ask. Okay, Anthony gives me thumbs up. Is anyone actually live coding with me? Because if no one is, I'll go faster. But if everyone is, I will go slower. Is anyone live coding?
I have it open.
All right, cool. We have one live coder. How exciting. Okay, cool. All right. So first, we're going to do exactly what Radhika did in the beginning of her exercises. we're going to take the libraries in Python that we're going to need, and we are going to download them. So we have a lot of libraries we are going to be using. So I'm going to just copy paste them because typing them out would take forever, and then I will just explain what they do. So in order to run any cell of data in JupyterLab, you click on the cell as we have clicked on it here, and you click play at the top. And, ooh, wow, okay. Is JupyterLab okay? Did I copy something wrong? Wait, actually, I think it's fine. Just a bunch of things are deprecated, which is strange. Okay, maybe there are problems within the library, but it looks like it should work. If it doesn't work, it's okay. I'll just upload the code I have and we'll go from there. Okay. I think this is just a warning. If it's not, we will figure out later. Okay, cool. So what do these libraries do? Ignoring the crazy warning we got. So NumPy, we explained. It's a way for us to do like numerical like arrays and things like that. Pandas is a library that allows us to do data analysis. If you guys take BME 202 with Professor Tariq and you use Python, you'll be doing a lot of things with pandas. It's a really great data analysis library. Matplotlib, like we said before, is just MATLAB. It gives you all the data visualization functionality of MATLAB, which is one of MATLAB's like big strengths. So between NumPy and MATLAB, or Matplotlib, you can essentially copy MATLAB, but in Python, which is super cool. Seaborn is another data visualization library. I think you can do cooler plots with Seaborn than with Matplotlib, but that's just what I think. Then all of these sklearns are all the machine learning libraries we're going to use. So we're using sklearn, but we're importing a bunch of different modules specifically from this bigger sklearn library. So the decision tree, metrics, which will let us measure the accuracy of our decision tree, and test train split, which will let us split the data we have into test data and training data. Does anyone have any questions about these libraries?
Sorry, I didn't catch where you copied them from, so I was trying to type them all out.
Oh no, okay.
Yeah.
I copied it from the very top of the file that you guys should have gotten. What it might be easier is you either open that in a text editor for you to be able to see everything, just in case it's not opening in your computer, right click and then open it in either Notepad. This is probably the text editors you have on your computer if you've not downloaded one.
Is this the student learn?
Yeah.
Or student exercise, sorry.
Oh, student exercise might be the one you guys are doing later on your own. Right now, this one is called Data Analysis Completed Demo.
Oh, okay.
That's that one. Just in case yeah, go ahead.
Can you repeat the function of the last one? Hold on.
Yeah. So sklearn is all the decision tree stuff, and that very last one in sklearn is the module we'll use to split our data. So we'll split it into training and testing data, because right now we have all the data and it's not been split yet. Does that make sense?
Yeah.
Cool. All righty. So hopefully I put it into the chat, Anthony, if that helps. Princess, do you have another question?
Yeah, that helps. Thank you.
So now what we're going to do is we're going to use pandas to read in our data as a data frame. So data frames are generally like the data type you're going to use for data analysis, because unlike just like an array or a matrix, it allows you to do, like, it pre-formats things like headers and stuff for you, and it just lends itself really well to analyzing the data because it's like a pandas data structure essentially. So what we're going to do is we're going to name our data frame. I'm just naming it df. That's like kind of just what normally you would do. And you're going to do PD because it's part of the pandas library, read underscore CSV. So just read our file in, and Titanic, which is the name of our file that we have right now. And then we're going to run it. Let's see if this runs. Okay, yeah, it ran. So the way you know it ran is because there's a number here on the left-hand side instead of a little star. The little star means it's running, and it hasn't run yet. So hopefully that means the errors didn't mean anything. So now, obviously, this doesn't tell us much. We want to actually see what's in our data. So how we're going to do that is we're going to use function called .head, and head will just print out the top 5 lines of our data frame. So yeah, that's what it did. This is, so Python indexing starts at 0, right? Not 1, unlike MATLAB. So this is 0 through 4. It's the first 5 lines of data, and it gives us the different columns, information about the data, information about our passengers, and we see we have some cool stuff, such as the full names of all our passengers, gender, age, and different things like that, type of ticket. Well, so we already knew this earlier because I had like a description of the data, but if we didn't know that, this would be super useful to figure out what's in our CSV file. All right, now, because just looking at the first lines of our data doesn't tell us much, we're going to use describe. Describe is going to give us statistical information on any numerical value. So obviously name is not numerical, so it's not going to give us like any statistical information, meaningful statistical information, but it is going to take all the other variables, all the quantitative variables, and give us information such as mean, median, standard deviation. This can be helpful if you're trying to figure out if some data is like normal, if you're trying to do that, we'll be doing that later. If you want to just figure out the range your data is in, things like that. It's not super useful for things like survived, where it's like 0 and 1. That's not necessarily helpful, but it is helpful, for example, if we wanted to know the average class people were traveling on, or the average number of siblings and things like that, or the average cost people were paying for the ticket. That's cool. We looked at that. The way data analysis works, what we're going to be doing right now, I should have explained this earlier, is we're going to explore our data before we analyze it. So that when we analyze it, we don't do something called GIGO. I don't know if anyone has heard of that acronym, but it essentially stands for garbage in, garbage out. You want to make sure your data is all cleaned up so it's not garbage, because or else your model is going to be garbage and your predictions are going to be garbage. So because of that, you have to first figure out your data by looking at it, and then you can clean it up and then stick it into your model. So what we're doing right now is just looking at it, which is called exploratory data analysis. Again, if you guys take 202 with Professor Tui, something you will be doing. So in order to understand at first, just the way our variables are correlated, specifically how they correlate to survival, because survival is the target variable. We're trying to figure out how all the other variables, like how they either contribute to survival, or how they or if they don't contribute to survival at all. So we might discover that, for example, I know passenger ID has nothing to do with survival, but we don't know that yet. But to figure that out, we're going to use a function called core, which just is going to tell us the correlation. So the way correlation works, if you guys take statistics, if it's you get a correlation of 1, that means they're perfectly correlated, like a perfect linear relationship, or a -1, because that means you get a perfect negative slope. And anything in between that just means it's not perfectly correlated, but you obviously want it to be super close to either 1 or -1. So if we do that, for example, we see, again, we're looking at survived. We see that passenger ID, which is literally just like the random ID they assign passengers, has nothing to do with survival, 0.005. It's a really low correlation. But things like the class they're in has a 0.3 correlation, which is a lot higher. And fare, how much they paid for their ticket, has a higher correlation with their survival rate, which makes sense. Obviously, from what we know, the higher class you probably were in, the more likely you were to survive and things like that. So that's interesting. We noticed that. But looking at just numbers is difficult. And looking at just these numbers can be really confusing. So we're going to create a graph that helps us visualize all of this better. So I'm going to copy paste this because it's a little long. We're going to use the Seaborn package. Again, we aliased it SB, which is the standard alias name. Pair plot. Pair plot is essentially going to graph these correlations for us in a way that makes it a lot easier for us to understand what's going on. So it's going to take a little while. But to explain what we're doing, oh no, it didn't work. Okay, sad. This might be where this error comes in later. Actually, wait, let me try this. This might be why.
Yeah, that's really strange.
Yeah, it literally worked last time. Let's see if this works. Ah, it did not. Sad. Okay. Well, unfortunately, we cannot see pair plot. You know, guys, give me 1 second. I'm gonna see if I upload my pre-made file, if it'll work any better. If it doesn't, we're just gonna have to skip this part. But if it does, oh shit, I might not upload it. I think. Give me a hot second. So this is essentially, oh, nice. Okay, so I already ran everything apparently on this file, which is pretty great. So if for some reason, literally the exact same code when I ran it before work, but I'll just explain it here. That just might be faster and easier anyways. So what we're seeing here is it's plotting every single variable against every other variable, which essentially is what this is doing here with the correlations. Oof, this is not the right data set though. Wait, let me see if I have the right data set. Sorry, guys. This is, oh, this is the incomplete one. For you guys to do later. And the last one. Wow, I named it a really useless name. This is it. It is not. Okay. All right, give me like 3 seconds and see if I have something else. If I do not, that is unfortunate. Here's what we're going to try. Okay, well, this is exactly what I just had, but it may not run.
Wait, what are we supposed to see?
We're supposed to see something like this, except for the Titanic data set. This is unfortunately for the diabetes data set that we're going to work on next, which for some reason runs, but the other data set doesn't.
I don't know. I ran it and I have a bunch in red, and then right under it, I have a bunch of plots.
Oh, no way. So it worked for you? That is so strange. Yeah, you should be getting a bunch of plots. Do your plots look like, they look like this?
Not exactly, but yeah.
Okay, well, they shouldn't look exactly like this. But
Oh,
they
right.
look like
Yeah.
Yeah?
Yeah.
Okay, that is whack. I don't know why it's not working for me then. Is there a problem with the
It
kernel?
didn't work for me.
It didn't work for you?
No.
Okay, interesting. Is the kernel you have on the top right, the Python 3 kernel?
Yeah, it is.
Okay. I'm starting the same error. Is it the Python 3 kernel for you, Anthony?
Yeah.
Okay. That is so strange. I'm not sure why it's working just for Princess and not for us. Oh, it worked. It just took a hot sec. Okay, great. So actually, Anthony, give it like
Oh,
a
yeah,
minute.
now it's there.
Okay, now it's there. Okay, yeah. All right. I don't know why we're getting this strange error, but you, Princess, you said you were getting an error too, right?
Yeah, I think it's that.
Okay. I think what's happening is, so essentially I have this argument called BW, right? And this is essentially what I'm doing is I'm setting the bin width. So as you can see for these graphs, the ones that are just distributions, I'm set this, technically they have like a width of a bin that I'm setting. And if you were to create a histogram, I think what's happening is that this argument is not something you'd use in PyCharm. So if I was coding this in PyCharm, I would just take this out altogether. But for some reason, Jupyter Lab was requiring me to use it, but at the same time also, I guess, spitting out errors. So I don't know, I think that's fine. But it's irrelevant now. So yeah, what we're doing is we've colored the data based on survival. So as we can see from this legend on the right-hand side, if it survived, it's blue. If the passengers survived, sorry, they didn't survive, it's blue. And if they survived, it's orange. So that helps us that tells us pretty much when you compare any of these variables, if there's something that like significantly predicts survival over something else. So we see a lot of blue in one section and a lot of like orange in another section. And again, they're plotting two variables against each other, except for these histograms here. I believe these are histograms. These plots are just plotting the distributions because they're passenger ID, for example, against passenger ID and things like that. So again, this can tell us whether there are certain variables that really correlate to survival. So you would look closely at this and decide. I already know like what variables correlate and which ones don't, which is why we're just going to speed through this. But in reality, you'd spend a lot of time looking at this data to figure out what you think is significant enough to keep in your data and what you should throw out, depending on what you think your model would actually find useful. Because we're not going to end up putting all of these different fields into our model, all these different columns, because that's, again, garbage in. It's like the sort of stuff that your model isn't necessarily going to need. So we looked at this. Go ahead, Princess.
Oh, wait, like usually we would have to decide that ourselves. We can't, you know, have some way to make it like help us decide it, not just by looking at it, but maybe like some actual numbers or,
Yeah, so sorry.
oh yeah,
Yeah, so you can definitely use numbers, and that's why we're gonna look at more numbers, and we're going to use like correlation and different things, and things like this plot will help us. But at the end of the day, it's kind of up to you to decide based on the information you already know about the data and what the data is showing you to decide which columns to keep and which ones not to. Which is actually, that's where like machine learning and stuff gets tricky in the real world. It's not the model as much as it is doing all this stuff, figuring out what's useful and what's not. Does that make sense? There are more numbers, and we'll go through more numbers. Yeah, you're not just gonna like randomly stare at data and hope that's enough. Okay, cool. So we generated the data, that is cool. And we noticed that there are, some of these columns are useless. Like we said, passenger ID is useless because it's just a random ID we assigned to passengers. And some of this other stuff is also less useful. So what I'm gonna do is I'm gonna start copy pasting code, guys, because it's gonna take us a while. Like I said, you guys do have access to that file. So as long as you open it, you can also copy paste with me. But what we're doing here is we're dropping the data that based on the definition of the data that we have here and what we see in these sort of graphs where we just know is useless. So cabin is again just the cabin number. It's not correlated to class or anything. Passenger ID is just the random ID each passenger got. Their name doesn't tell us anything about their status, and their ticket. It's like this is like their ticket type, which again not useful. So we're gonna remove that, and if we look at our data, we're going to see. Oops, we're gonna see that those columns got removed. If we, df clean. I renamed the data frame. I created a new data frame called df clean, so that we would still have access to original data frame if we wanted to. So if we do df clean, we'll see we have much less data now. Okay, cool. Now what we're going to do is we're going to see if we have null data, because our model can't do anything with data that's null. So from now on, again, we're going to be using df clean. We're going to see, is there any null data? So is null is a function that will tell us if we have any null data. And we're going to do .any so that we can just quickly look at our data and understand if there's any null data. So false means that in fact there was no null data, which is good. We want all of these numbers to be false. But you see we have some truths. We don't have all the age information for all the different passengers, and we don't have embarked, which is the city they embarked in. We don't have all that information. So when you have no data, you can either remove the data altogether, or you can replace it with like a mean value or a median value so that we don't have to throw away the passengers altogether. So what we're going to do is embarked data is not really useful for us. Where they get off is not, or where they get on, I believe that's what embarked is not useful to us. Either way, it doesn't really correlate to survival. So we're not going to be using that. So we're going to do exactly what we did before, where we're going to drop that column embarked. I'm using .drop, which is just a function. This should work. And embarked we note is in a list. That's just how this takes data. Ooh, we got columns. All right, cool. So again, if you look at that, oops, I keep printing PDF. There's no more embarked. So that's good. We pick that out. And now we're going to find some way to make up for the age data. So there are two things that we can replace numerical data with, because age is numerical data, the median or the mean. If the data is normally distributed, we'll use the mean, because the mean is obviously a pretty representative data point that kind of represents all the data. And you could probably replace null values like that without affecting the skew of our overall data. On the other hand, if the data is skewed positively or negatively, we're going to want to use the median, because that will prevent the data from being skewed, because you're replacing all the nulls with a different value. So in order to that, we're going to have to see how the skew of our data. The way we're going to do that is we're going to plot it the same way, just so we can look at data. So I, again, copy paste this straight from the notes. I have. But we can see that this data has a, I believe, positive skew. That's what it is when it's like tilted up to that side. So that means we can't replace the null values with the mean. We have to replace it with the median because the data is not normally distributed. So we're going to go ahead and do that. We're going to replace all the data, all the age data with the median value. Again, I'm copy pasting it because it's a bit of a long line of code. What we're doing is we're using the .lock function. .lock function, what it's going to go through and do, it's going to say, it's going to go through the age column of our data frame. And it's going to say everywhere the age column is null, it's going to replace it with the median value. So it's taking this age column, so it's taking the row. So this is rows and columns. It's taking all the row values where df.age, so the age column is null, in the age column, and it's replacing them with the median. Does that make sense? It's kind of a hefty line of code. Good. Awesome. Thank you for that. So now we are going to look at our, or actually no, we're going to do the is null again. So this should tell us. Now they're all false. That means we have no more null data. We did a good job. We cleaned up our data. So now we have looked at our data. We have cleaned up our data, which is pretty awesome. We are ready to build our model. Usually I would go through and look at the data some more in order to find out specifically what variables we think really correlate with, actually, do we have time? We are running low on time. Okay, very quickly, I'm going to show you guys this. Hopefully it works. Let's see if it does. So this is just a plot I put together. This looks really complicated, but most of it is just formatting. We just want to look at survival, class, and gender and see if there's any relationship between these variables. Oof. Name axis not defined. Ooh, I was going to create a subplot. So subplot is essentially when you create two plots side by side and it just looks nice. So what would have happened is I had another plot that was going to go on this left-hand side, which honestly I can show you guys. Again, if you guys look through this code on your own time and understand what it's saying, but essentially they're just different types of plots. You guys have definitely seen these types of plots before. The rest of this is just formatting. Ooh, this is what Radhika was saying about how white space matters. All right, cool. Yeah. So essentially here I was just looking at how many people died and how many people survived, just to understand that, wow, more people died, which we knew, but like if you didn't know. And then I wanted to see if like gender played a part. We can clearly see gender played a part because whatever class you were in, if you were female, you had a far higher likelihood of survival than if you were male. But we also see that, class also played a part because generally third class survived far less. So based on this, we probably predict that gender has a higher affects survival more than class, but that's just a hypothesis. Our model will tell us that. Okay, cool. So now very quickly, we're going to get dummy variables. Since I explained earlier that we were going to be getting dummy variables for gender, I'm just going to do it. There's just a function called get dummies. We're just going to be using that. So for specifically the sex column. So df clean final is the name of my final data frame. And we can look at it here. Oops. Oh, okay. We're not going to look at it here. Actually, we can. Okay. So you can see there's a column called sex female and a column called sex male. What's actually interesting about this, what's interesting about this is we can actually drop one of the columns because again, we're living in unfortunately a gender binary data set. So that means that if you're not male, you're female. So actually I'm going to drop one of these columns because there's just no need for either. So our model will just take longer if you have extra columns. So all I did is I dropped the sex male column. So again, if we were to look at this data again, I set it equal to X. So X is my name of my new data. There's only sex female, so we just dropped sex female as a column. So what I've done here, I kind of brushed over it. I have a Y variable and an X variable. X is every single attribute that's going to affect your target variable. So passenger class, age, sibling, and all these different things. And Y is our target variable. I just set it equal to survive. So all the survival data is in our Y variable, and all the other data that is possibly relevant is in our X. this is just, we divided the data just because that's how our function is going to take it to create our model. So very quickly, I'm going to pause for questions because we're about to start training our data. Anyone have any questions about what we've done so far?
Yeah, I think I kind of got lost around like the two plots side by side.
Oh yeah, this was just data exploration. This looks like a lot of code, but most of it is just like setting axes and labeling things. But essentially, this was just us trying to figure out which variables affected survival. Because we hypothesized, I hypothesized when I was coding this, that class and gender would play a big role in survival. So we just wanted to see if that seemed true at all. And it does seem to be true, but we won't really know until we create our model and our model tells us if that was true or not.
All right. And are the indentations like important?
Yes. So before, what I had done is I accidentally had like white space like this, and it gave me an error. You can't have like that sort of random spacing. Here, because it's all they're all arguments of this point plot function, it spaces like this automatically. Like PyCharm will space like this, or yeah, essentially any text editor will space like this if you have like one really long line. Technically, this whole thing is just one line of code. That's really ugly to look at. So it's spaced like this automatically for me.
Yeah, okay, thank you. Yeah.
Cool beans. All right, so we are dividing our data set. All this is doing is dividing our data set into training data and testing data. 30% of our data is for testing. That means 70% of our data is for training. And this function takes care of it for us. So we don't have, the nice thing of this function is, well, normally when it works, the nice thing about this function, I think it is working. Again, these are just more warnings. I don't know what's been deprecated, but something has been deprecated. It's just something in NumPy is no longer being used, and we're throwing issues, but it worked. We're just, again, like I said, dividing into training data and testing data, and this line of code is doing that for us. And the only really relevant argument here is this 30%, because that means 30% of it is testing data, and 70% of it is training data. So yeah, this is a sort of line of code that you would probably copy paste for like every single model you make. At least I do. Okay, so now we are going to actually create our model, and it's literally one line of code. We're going to just create a decision tree with just 5 nodes. I'm just going to do 5 nodes because it's easy and it won't take forever to run. In reality, this is when you would try a bunch of different amounts of nodes, and then you would like overfit it and then come back and like prune it back. But we're not going to do that. We're just going to assume 5 nodes. Because finite nodes is nice to look at. All right, and now we're going to fit our model to our training data. So this is just training the data, like training the model, like we mentioned earlier. And we're using our training data for it. Again, we're getting that strange error, but things are working, so it's okay. So then it's giving us more information about the actual model, which would be useful if, but we're not going to go into this sort of detail today, so that's okay. Later, if anyone is curious about more of these things, I can help explain it. But for now, this is good. Now we're going to predict values for our testing set. So we created our model. That went really quickly. It took us like 2 minutes. But we created our model and we have trained it. Now what we're going to do is we're going to test our model using our testing data that we already divided up and set aside earlier. So to do that, we're going to predict Y values. So we're going to predict survival for the testing data we have. And that's all. This is just using the predict function, using the decision tree module we've been using. And we predicted the data. Obviously, that didn't actually tell us anything because we didn't have it display anything. So we're going to have it display is some numbers to tell us whether our model was accurate. So this is how accurate our model is. Our model, 82% of the time, that's this 0.82, it's just in decimal format. 82% of the time, our model predicted whether or not a passenger survived or died correctly, which is pretty good. You know, 4 out of 5 times it was correct. So we could probably say this is like a decent model. Again, we didn't exactly test it using, you'd probably go back and want to test it using more different like depths. So seeing how far out you want to go with the decision tree. But seeing as we didn't have that sort of time to look at that, we have a model that's 80% good. So that's nice. If we want more data, if we don't want to just look at a number, but we want to look at a little more visual way of looking at it, we can use the confusion matrix. So confusion matrix essentially is just going to tell you true positive versus true negative. So this is true positive. That means 141 passengers died and our model correctly told us they died. 81 passengers survived and our model correctly told us they survived. Then there were 24 passengers who, if I'm not wrong, we should have said they died, but our model said they survived incorrectly. So that is a false positive. And then here we have passengers who should have survived, but our model said they died. So these are false negatives. So this can, sometimes certain models you don't want, like false positives would be really dangerous, or like false negatives. For example, it would be really dangerous if you had like a model that was going to that told you whether or not you had cancer, and it went around telling people who had cancer that they didn't have cancer. It would be far more dangerous for you to have that than if it told someone who didn't have cancer that they did have cancer, because while testing and the mental burden of a false diagnosis would be horrible, it would be really horrible if you had cancer and the machine didn't tell you. So sometimes you'll have models that you want to optimize for either false positive or false negative. You'll dive into that in statistics, which is BME 423. But for now, this is just a useful way of seeing what your model does right now. So you can change that if you need to later. And finally, let's actually look at our model, because right now it exists, but we can't actually see the pretty tree we made. So this is just a function to tell you the tree, or to show you the tree. Again, just a couple lines of code, pretty simple. But this is the model we created. These are the questions that your model is asking the data to figure out if people died or not. So again, if it was orange, that means these nodes had people of high survival. If you went down this path, you would have a high chance of survival. These blue ones mean that they have a high chance of not surviving. So yeah, this is the model you created, that you just trained and created, and that you can use now to predict whether or not a given passenger would live or die, which we will do now very quickly because we don't have a lot of time, but we have a minute, so we're going to do it very quickly. So what we're going to do is we're going to just very quickly remind ourselves of the columns, as in the columns we use in our data. And now we are going to see if a passenger survived or died. So does anyone want to be my passenger for the day, to figure out if they would have survived if they were on the Titanic? Anyone? Is anyone curious?
Yeah, sure.
Okay, cool. Princess is our variable. So Princess, what class were you? Or do you want to be?
I'll take 2.
You'll take 2? Okay, nice. Average number. So I'm just matching it up with these columns. How old are you?
18.
18. Oh man, you're young. How many siblings do you have?
1.
1. Okay. What is Parch? I think Parch might have been how much you paid. Let me just check. Oh, number of parents or children. So how many parents or children would you have taken with you on the Titanic?
3.
3. Okay, cool. How much did you pay? So I think people paid anywhere from like 7 to like 750 for their ticket. So how much did you pay?
725.
Okay, you paid a lot. Honestly, that alone probably means you survived. And you are a female, so that's a 1 there. Okay, so I created an array with your data. We use NumPy to create an array, which is, we sort of mentioned earlier. It's just a list that gets converted to an array. And now what we are going to do is we are going to predict. I'm just going to copy this. The predict function is a little weird, so you have to reshape the array, but that's just semantics. Essentially what we're going to do is we're going to take you, Princess, see if you die or live. Hopefully you live. You got a 1. That means you lived. Good job. You survived the Titanic. But yeah, so we are actually a minute late, so I'm going to go ahead and stop for now. We did have to skip over a couple of things and go a little quickly, but does anyone have any questions?
Yeah, can you, I think there was a point where you had like wrote decision tree or whatever.
This or higher up?
Higher up.
Okay.
Right there. Like right under that red.
Right under the red? Oh yeah, this.
Oh,
so
under the second red.
Oh, under, here?
Yeah.
So this, because I was fitting the model to my data, it was just giving me details about my model that it created. So this is all the default options it used. So this is like the type of we didn't go over this, but this is like Gini index. It's like a type of algorithm to decide that splitting thing we were talking about. We didn't set a lot of these, like arguments, but if you were curious about the model you created, you could go back through and see what arguments are the default arguments and what sort of model we created. That's essentially what this is telling you.
Okay.
Again,
Yeah.
if you Google this function, you would get a lot more information about every single argument here.
Yeah. I don't know why I got an error here.
Oh.
Okay.
So like nothing after that worked?
Mm-mm.
Did
Yeah,
you
that's
do?
where I got lost.
I glossed over like this y. Did you set this y equal to the survival data and then x equal to this part?
Yeah, I did.
Okay. Then I would recommend going through maybe and looking at the sample, well, the filled out version of this that I gave you guys. Maybe you missed a line somewhere. Or maybe you're getting something like this where it's like something funky going on with the libraries that doesn't have to do with ours. All right, I don't want to keep anyone else who is probably hungry.
I kind of just want to see it run
Yeah.
with like a different
Passenger?
passenger. Yeah.
Yeah. Is Anthony our new passenger?
Yeah, sure.
All right, Anthony, tell me, what class were you going to be in?
Well, actually, let's say 2 as well.
Okay. How old are you?
Then 18.
Uh-huh. Jeez, you guys are so young. Is that not young? It's not.
I think same 1 and 3 for those
Okay.
2 as well.
Oh, you just want to see if you were male, if that would make a difference?
I'm also going to lower the ticket
Okay, the fare, yeah.
to like 70.
70. Yeah, I'm not gonna lie, Princess got ripped off. She paid a first class price for a second class ticket, which is a bit unfortunate. Sorry, Princess. That run? Yeah, okay. And then I'm gonna reshape, do the same thing. Oh, you died, Anthony. That's so sad. Tragic. I'm sorry. So sorry.
I just wanted to
Wasn't
see how
enough.
it worked.
You know what's actually one really interesting thing I'll do, sorry, and then I'll let you guys go, is you can actually see which features were most important. So as in which things actually affected the model the most and affected survival the most. So this again is aligned up with, I'll just put out the columns again so you guys can see it all on one screen. Or actually, if you guys can see it on your screen, yeah. So again, it's just in this order. The higher the number, the more important this feature was in predicting final survival. So we can see 0.5, which is gender, was the most important predictor of survival, which is 0.5, which is really high. It's out of 1. So that would make sense why Princess, fair aside, why Princess survived and Anthony didn't. So.
Okay, so let's try it again with like my data with like 70, the price, just out of curiosity.
You want to try it again?
Yeah.
Okay, let's see.
But yeah.
Let's go 70. Fair seems sort of important. I don't know. Oops, I have to rerun this line. Yeah, you still survive, which makes sense based on what our model is telling us. Yeah. All right, very cool. Again, I don't want to keep you guys, kept you long enough, but if you guys have any questions about this, please reach out to me. If you're interested in doing more Python machine learning stuff at a very basic level, I got all of this from the ITP machine learning class, which was pretty good. I have a minor in applied analytics, and it was one of the classes I'd take for it. If any of you guys want to like talk more about that or anything, please reach out to me. But also, before we go, I'm going to just also throw the Medtronic form for the Medtronic technical workshop we're having in 2 weeks, because that will be super great recruiting opportunity, and also I want all of you guys to come. So yeah, please RSVP to that. But I don't have anything else. So if you guys have questions, feel free to stick around. I'll stick around. But if not, I will see you all later. Thanks for coming.